So we started developing Detox a bit over a year ago out of a need for a tool we can trust with our end-to-end tests on mobile apps. We had a big problem where non-deterministic tests runs were too common. We couldn't rely on our own test suites and spend too much time maintaining them. After a year of building and using it as part of our development and release process, we've gathered some insights, and I want to share them with you today. So hi, I'm Rotem. I'm a part of a mobile infrastructure team at Wix. My team owns the mobile stack across the company, and we mainly do infrastructure work, devoting lots of our time for testing infrastructure and methodologies. And the unique thing about the work we do is that most of it is open source. So let's just dive in. Flakiness. End-to-end tests are often considered to be flaky in all platforms, web, iOS, and Android. Tests may fail without code changes. Tests are non-deterministics, where too many moving parts inside the app. They may finish executing in different order or different timing or on different runs or environments. The uncontrolled inputs may vary between tests. We can't really be sure when the application is idle. So users of end-to-end test frameworks usually deal with synchronization manually. So they use multiple slips functions just in strategic locations just to make the test pass. So this is an example I took from Aaron Greenwald's talk from React Amsterdam. This loop around driver slip is what we actually would do to try preventing flakiness in previous testing platforms. How unreliable a flaky test suite is. Let's calculate the probability of a test suite to fail. So 1 minus q is the probability of a single test to succeed. 1 minus q at the nth power is the probability of the entire suite to succeed. 1 minus all that is the probability of at least one test to fail. So if a test is flaky 0.5% of times, then if we have 20 tests, we have around 10% of failing test suites. If we have 50 tests, 22, and 100 tests, well, you get the point. It's very unreliable. So we used Appium for 2 years in general and 8 months with React Native. And we found that we've been investing a lot of time running tests and petting the system than actually writing features. So we found that end-to-end is really hard because tests were flaky. We got different results on different machines, frequent failures in CI, and mostly, and the only solution was the addition of those slips I spoke about. So, which of course slowed the tests down, and the benefit of testing must outweigh the cost. And frameworks which are complicated and fragile can occupy a big chunk of our time. The main characteristic of the frameworks of this kind is that they do black box testing. What is black box testing? So it's a method of testing stuff from the outside without knowing what's going on the inside. In mobile, Blackbox MultitoE essentially goes over the view hierarchy, looks at the element. If it's not found, it sleeps, then continues looping until an arbitrary timeout, which we choose or the framework chooses for us. If it's found, the framework then interacts with that view. Same principles are applied to web Blackbox MultitoE. So now, think how unfair it is to asking the users to provide that timeout parameter. They have no idea what's going on inside the app. They have no idea what's going on inside the system. And this is the main cause of flakiness. So for us, Blackbox was a dead end. So we decided to change some of the core principles to our testing approach. And we created Detox. Detox does Graybox testing, not Blackbox, like the other frameworks, to allow test framework to monitor the app from the inside and actually synchronize with it. Graybox essentially uses a piece of code that is planted in the app, and it can see what's going on inside. So unlike Blackbox, Graybox runs in the same process. It has access to memory, and it can monitor the execution process. Being able to read internal memory gives it the ability to detect what's happening inside the process what's going on with network requests, and if the main thread or the other threads are idle, if animations have ended, or even if the React Native bridge is idle. So it can execute on the main thread. This means that it makes sure that when it performs an action, nothing changes under the hood. The main thread is busy doing that instead of just changing the UI. But it also have downsides. Usually when testing Graybox frameworks, the app goes through different compilation or running process, since it needs extra code to be executed inside this process. For us, it was worth sacrificing this point to get a huge value in return. So how Detox works. The leading native Graybox drivers are developed by Google, Earl Grey for iOS, and Espresso for Android. These frameworks can synchronize with the application, making sure they only interact when the app is idle. The underlying synchronization mechanism used in these Graybox frameworks works in the following way. So instead of retrying an action assertion on the UI, they will query internal resources every few milliseconds, or listen to callbacks from them, telling them that they have now switched to idle mode. The test will not continue until they are idle, and only when they are idle, it will interact with the UI. Detox does not rely on WebDriver, since this is not the web, like other frameworks. Detox communicates with its native driver, which extends Earl Grey and Espresso inside the app, using JSON-based reflection mechanism. It allows common JavaScript implementation to invoke native methods directly on the device. So this is how a simple Detox test looks. There is no need to synchronize or add sleeps or wait for stuff to finish. Detox is inherently synchronized with, it executes the commands only when the app is idle. It is cross-platform. Test code is unaware of the platform it tests. It is test runner independent. So this example is with Mocha, but we're not picky. And it is debuggable. So because we're using async await, so instead of putting everything inside a promise queue, this means that if you put a breakpoint, it will stop as expected to. Traditionally, test frameworks evaluate the expectations in the test script running on the computer. Detox evaluates the expectation natively on the device. So running on the simulator or emulator, this enables operations that were impossible before due to different scope or performance reasons. So, okay, let's take a look. I'm going to go quickly over this. This is a high-level diagram with a few examples. We can understand how everything works, all the parts in the system. So the test runner runs an action or expectations and awaits on a promise. That's all. And then the tester is the Detox code that runs inside Node. It creates a serialized nested invocation JSON that is then being relayed through the server to the testee. The testee is the device itself. The testee then, the action or expectation is invoked through method reflection on the device, but then it is only being executed when the application is idle. So then the invocation result is being sent back through WebSocket, and the promise is being resolved or rejected. That's it. So in the past 9 months, we've been using Detox to automate or improve our release process, and we've used multiple testing scenarios, crunched tons of synchronization bugs, and came to a few understandings on what makes sense when testing with Detox. So here is a testing pyramid. It was very popular here today. So the mandatory do not write lots of E2E tests, focus mostly on unit and integration tests, must be applied here. But seriously, I cannot emphasize enough the importance of unit tests. You should put most of the effort in running them. That's at least in my opinion. End-to-end tests are there to verify the end result works and the integration is not broken inside your app. But we're not going to talk about unit tests now. In general, there are two types of tests my team uses Detox for, production MultitoE and MultitoE. This is UI automation. So the main characteristics of production MultitoE is that it involves every part of the system. It's the closest thing to a real user. It has many uncontrollable variables which can affect the test outcome. If the network is down, the test will fail. If our servers have issues, the test will fail. If test gets different A/B test variant in each run, the test will fail. So production MultitoE, the pros of production MultitoE is that these tests are run as close as possible to a real user experience, logging with real users against production endpoints. They're very, very, very easy to set up. You actually don't need to do anything. And they're very easy to write. Just find an element, interact, and expect something to happen. These tests can provide very high confidence if they're not flaky and slow. The main benefit about them is they can help QA engineers replace manual testing methods. But again, it will never be rock solid as, so therefore they're very hard to maintain. MultitoE tests, on the other hand, tries to eliminate all this by setting a controlled and predictable environment. So replacing all the endpoints with mock servers and data, and servers and client communication can be tested with contract tests. So if you put this aside, we test everything with contract tests, then we can make sure that we don't need that anymore. We don't need a server anymore with our E2E. So just a quick side note, which is not that quick. React Native is very challenging when it comes to testing. Unit testing is pretty easy most of the time. You usually test either JavaScript code or native code, and there are very good tools for each of them. But when it comes to testing integration between them, things become a bit trickier. So since React Native renders a native layout, mocking React Native JavaScript API results in very limited tests. So same like shallow rendering. So in the absence of a better tool, I believe that MultitoE is the best approach for integration tests with React Native. So MultitoE, the pros of MultitoE is that it is closer to the code, closer than production MultitoE. It is much more stable because we're using mocked endpoints, and this is a controlled and predictable environment like we wanted, such that provide the same input and in every test iteration. And they're very easy to maintain. Once they're written, they should just work. The cons is that they require much more setup. They're much harder to write since we need to take care of mocking and controlling mock data rather than server or local configuration. So how can we mock with Detox? I'll focus on React Native, but this can be done with Gradle build flavors for Android or with configurations on iOS. In order to use a mock server, we need to make sure the app it should not try to connect to a real server endpoint. So our way of doing that is by creating a different flavor of our JS bundle, one which uses different endpoints on our production app than our production app. So it turns out this is already supported by Metro Bundler, and by creating any file.e2e.js, we can override any file.js and create a custom JS bundle. So with very little modification, React Native can also support multiple build flavors. And in fact, there is a pending PR to React Native made by one of my team members. So if anyone knows a React Native team member which is watching this, so please come and let's talk. Let's discuss this PR. Anyway, until this PR is merged, we created a simple way to make it work. That's how we use it, by adding React Native repackager as a dev dependency. Its post-install script will just alter the React Native code, the build script code of React Native, and we'll add this functionality. So we'll create endpoint.e2e.js alongside endpoint.js, and by adding rncli config.js to root directory of the project, get source, and setting get sources ext, we'll prioritize it by giving a source extension over the default one. So by triggering each of these commands on the bottom here, the bundler will take e2e.js over the .js. So instead of building endpoint.js, Metro will now bundle endpoint e2e.js. This is an actual test from our MultitoE test suite. Mock server is an object that lives inside the test runner node process. It can be altered during the test using simple function calls. Once we set up with mock data, the test will launch the app. Now we can run mock tests that verifies that the application can persist login information and does not show login window in subsequent launches after the users have logged in. Another method that is worth mentioning is testing the application output by gathering requests going out of the application and running the expectations on the mock server itself. So in this case, we see a simple notification server that records registry and unsubscribe requests. And by triggering the application to send those requests, we can make sure that they're being sent correctly. So launching the app from a freshly install, then logging in and checking that the server still didn't get the device token. Then clicking allow inside the app, and then this should send the registry request to the server, and then we validate on the server that we got the token in the registry request. So we incorporate both E2E methods in our development and release process, or at least that's where we're aiming. Setting our goal in continuous deployments, we're working very hard on lowering our reliance on manual QA. This is our almost zero manual QA plans to be implemented in the short to midterm. So developers write unit tests, they write MultitoE tests and contract tests as part of their product development. This is incorporated in CI. Every build on every commit runs these test suites. They shouldn't take long time, between 5 to 20 minutes, and they will generate a short feedback loop to the developer. Yeah, this. So the QA engineers will use Detox to automate their regression and progression suites. These tests will never be as rock solid, hence they will be decoupled from the development process. They can eliminate most of the manual work that the QA does, and when a test is broken, it can be tested manually. The scenarios are owned by the QA team. Now, developers and QA are obligated to synchronize between them. The QA will need to educate the dev team on how to write high-quality scenarios and review MultitoE suites. And by having a good grasp on what all is already covered using MultitoE, the QA can reduce the amount of production E2E to the bare minimum. So this is mainly the plan that we're striving to in the next coming months. I hope we'll have good results. So now, if I'm going back to Detox, this is our plan for the near future. I don't know if any of you know Detox or what's missing for you in Detox, but for us, what's missing is we want to make it even faster. I don't know if anyone tried, but it is pretty fast. But we want to add it parallelization through test runners. Test runners that support parallelization will be able to actually run multiple simulators or emulators. We want to run on real iOS devices. Android devices are already supported. We want to generate artifacts from every test. So screenshots, videos, and logs will be created inside an artifact directory. And we do want to make better error logging, which wasn't one of our top priority, but now it gets there, and lots more. So that was me. I'm writing about Detox and other React Native related stuff on my Medium. So follow, clap, or don't, though I do mind. So thank you.